David Smith here with one more Flip Classroom math video. 3 tips before we start. First, you can increase or decrease the playback speed if that helps you get through the video. Second, you can pause the video at any time to catch up with your notes. Third, you can turn on the captions to watch my words go by on the bottom of your screen. Today's lesson covers cubic functions, which are also called power functions. So let's check this out. The general form is f of x equals ax cubed to the third power. That's where it gets this cubic function name, plus bx squared plus cx plus d. So unlike with a quadratic where we have 3 terms, with a cubic function we can have up to 4 terms. Now there's some special conditions here. A can't be 0, and that makes sense. If a was 0, we wouldn't have our cubic term, it would just go away. So a has to be something. And then A, B, C, and D have to be members or elements of the set of all real numbers. So, having said that, let's look. There's a couple, 3 examples here that we can have. We could have f of x equals 2 times parentheses x plus 2 cubed. We could have f of x equals 3x cubed plus 2x squared minus x plus 7. And finally, we could get something like this. F of x equals 0.5x minus x squared plus 6x minus 9. Now, just keep in mind that the only thing you have to have is some cubic term. Okay, here is the mother function for a cubic function. This is the most simple function. Just like with quadratics, you have f of x equals x squared. For a cubic function, it's f of x equals x cubed. This is the most simple function in this family of functions. And it kind of looks a little bit like a parabola that had its leftmost limb focused down. Let's put our arrows on here because this goes on forever. Now let's take a look at the max and the min for this function. Unlike a parabola, it doesn't have a max or a min. It goes as far as it wants down or up, so that's the y direction, and it goes as far as it wants left and right. So you won't get a max and a min with this function. In this case, we are passing through the origin, so that is our x, and our y-intercept is right there. It's just the point 0, 0. Okay, let's look at a couple more examples of graphs, and then what we're going to do is we're going to jump into Desmos. I'm going to put in some functions, and we can show how the various coefficients and presence of certain terms affects the shape and the intercepts and the mins and the max of this function. So, unlike the one I put on the last board, these two are considerably more complicated. Let's take a look at this one. So if we change the coefficients around a little bit, we can get a function that climbs up to what we would call a local maximum. The function as a whole doesn't have a max, but this is a local maximum where it comes up and then comes back down. And then this is a local minimum. These are also called turning points for good reason, because the function goes from increasing to decreasing, and then here it goes from decreasing back to increasing. So there's the max and the min on that graph. Now this one happens to have 3 x-intercepts. Here it crosses the x-axis, here it crosses the x-axis, and there it crosses the x-axis. So I've labeled those x1, x2, and x3. Those are the x values. Of course, when it crosses the x-axis, the y value is 0. Now this one also has a y-intercept. In fact, they all have y-intercepts. And this one is crossing the y-axis at this point, y1. And of course, the x value at that point is 0. Now check this one out. I've just taken this graph and scooted it down a little bit, and it's changed things a little bit. Now we only have one x-intercept at x1. We still have a max and a min and a y-intercept. Now you can get all kinds of variations of these. In fact, let's hop into Desmos and explore. All right, let's take a look at some of these functions and their variations using Desmos. Now I'm not using the graphing display calculator because that's just a little bit more complicated. It doesn't give us quite a big a screen. This I can go a little bit quicker and show you the variations more easily. Just know that you do need to be able to use your calculator to graph these functions, gather their minima, their maxima, and their x and y intercepts. So let's go ahead and get started. Okay, so here I am on my Desmos screen, and I'm just going to put in that very basic mother function here, and that's y equals x to the third power. And check it out, that's real similar to the one I just put on the board. I can zoom out and it looks a little bit more pointy. I can zoom way in and it tends to spread out a little bit. Okay. Okay, so all cubic functions are a variation on this one. And unlike with quadratic equations, which make parabolas, the variations on these can be quite different. So let's play with some of the basic ones first. If I just add a number after the function, you can see that I've made the function go up 2. If I subtract a number, the function goes down 2. Now, if I go ahead and change that to putting the number inside the function, so now I've got it inside the squared. Notice how I added 2 inside there, again, orienting to the function on the left. You can see that the function of the graph of the function has moved 2 to the left. And as you would expect, if I do a -2, it moves the graph of the function to the right. So you can see here that constants added in, either in the cubic term or after the cubic term, simply move the graph around. They do not change its shape. Okay, so let's play with another one that's going to do a little bit more than that. All right, so I'm going to leave x cubed on there and start another graph so we can compare. So let's do y equals x cubed. Oops, let's get that better here. X cubed. And then we're going to go ahead and add 2x squared to that. Now notice how on my graph, I now have a local maximum and a local minimum. And I say local because the function does not have a maximum. I'm going to scroll out and you can see that this function climbs up and up and up and up and up. It's going to go up forever. It doesn't have a maximum. And the same thing going down, it's going to go down forever. So it doesn't have a maximum or a minimum, but it does have a local one. And I've got one right there. That would be my local maximum, and this would be my local minimum at the origin, the point 0, 0. So let's check this out. Now I'm over on the left, and I'm going to change that to a -2x squared. And notice how it just scooted it down. So now I have my local minimum on the right side, and the maximum is going through the origin. If we change that to just x squared, it just de-accentuates that. It's not quite as much of a curve, but you can see we still have maxima and minima. Let's go ahead and I'm going to take that out. Now take a look. We're back at our mother function, just the y equals x cubed. And you can see here that we have one x and one y intercept. And that's where the graph crosses these two axes, and that happens at the point 0, 0. So we always have at least one of each of the intercepts, unlike with a quadratic where you could have no x-intercepts for a parabola that's fully above or fully below the x-axis. But with a power function, a cubic function, you're always going to cross both axes. Now let's get this one back in there. We're going to do x cubed minus x squared. And you can see now that this function has two x-intercepts. We're going to go through 0, 0, and then we're going to go through the point 0 or 1, 0. So we have two x-intercepts. We still have just one y-intercept at the point 0, 0. And then like before, we have our local maximum and our local minimum here. Now let's go ahead and make this a little bit more complex. I'm going to go ahead and add a plus x here. Remember how we can have a cubic term, a quadratic term, and then an x term, and then a constant. And check it out. That's made this graph smooth out quite a bit. We lost our local max and our min, and we went back to having just one x-intercept. Now let's change this x term a little bit. Let's make that 2. Notice how that made the graph even more straightened out. Let's try 0.5 in there. And now it looks like we're getting it a little bit more curvy again, but still we don't have a local max or a local min. But let's try minus 2x. Whoa, and now we've got our local max, our local min. We still go through the origin, the point 0, 0, but now we have an intercept at -1, 0, 1 at 0, 0, and 1 at 2, 0. Our y-intercept is still the same at 0, 0. Now, of course, if I add a number at the end, let's do minus 3. Oops, I did that wrong. Let's try that, minus 3. Now what's happened to my graph, I've scooted it down, so I still have the same shape, but I now only have one x-intercept. Check that out. I've moved it down so this little local maximum no longer crosses the x-axis. So I only have one intercept instead of, like if I take away this 3, now I have 2. Okay, so that's kind of an interesting feature of how that goes. I think I've showed you everything that I want to show you about this. I want to make a point here and then we'll jump back on the board and I'll show you how to do that. The problems that you're going to get in our textbook are going to ask you to use your graphing display calculator to pull up a graph of a cubic function or of a power function. And you're going to look at that graph and then you're going to be asked to sketch that into your exercise set. Basically make a hand graph based on your graphing display calculator showing you the graph of the function. So the key thing for doing that is to plot the intercepts. So in this case, I have an intercept at -1, 0. I have one here at the point minus 0.549, 0.631. I have another intercept here at 0, 0. That is the second x-intercept and the y-intercept. I'm sorry, I misspoke. This is a local max, this point here. And then we go down here, I have a local min down here at this point. And then finally, I cross the x-axis a third time at the point 2, 0. So what you're going to need to do is use your graphing display calculator to find these points. You won't always have 3 x-intercepts, but you'll have at least one, and you'll have a y-intercept, and maybe you have a local max and a min, maybe you don't. But you need to gather all the points you can, plot those on your graph, and then once you've done that, you can connect the line for your power function. So that's pretty much what you're going to be asked to do. So let's jump back on the whiteboard and do a hand graph based on a situation just like the ones that we've been exploring right here. All right, let's take a look at how to make a hand graph. Now, this treatment here assumes that you've already gone on your graphic display calculator, you've graphed our function, x cubed plus x squared minus x minus 0.5, and you've gleaned this information off of that display. Okay, my x-intercepts are these 3. So let me go ahead and mark them on my graph. I've got minus 1.50, that's right there. I've got minus 0.40, so that's right about there. And just a note, I have rounded these a little bit just to make the graphing easier. There's a lot of decimals in some of these because these functions are complicated. And so they don't generate like really clean intercepts like a lot of quadratic equations will do. Okay, my last one is 0.90. So that's 0.90 is going to be somewhere right about there. Okay, so those are my 3 x-intercepts. How about the y-intercept? That's 0 minus 0.5. That's going to be right there. Okay, and then now these are going to be important because they're going to kind of show us how the graph works. So my local maximum is at minus 1.5. So minus 1.5 right there. And then my local minimum is at 1/3 minus 0.7. So that's 1/3 minus 0.7. That's going to be somewhere around in there. So I think you can kind of see how this graph is going to go. Plus, if you got this information, you're looking at the graph on your calculator. So this next step should be pretty straightforward. However, I could give you a test or a quiz question that would just give you this information and ask you to make a hand graph. So you need to be able to do that without looking at that graph on a calculator. So when I take a look at these numbers, I realize that that's a max and that's a min. So it has to come up to that and go back down. That's a minimum. So it has to approach that in a decreasing way and then turn, that's a turning point, and go back up. So we can see pretty clearly from our points and what we know of them that this function is going to come up, peak there, drop back down, cross the y-axis, and then come back up. So I'm going to do my best to make that a sketch. So there it is. I did okay. I guess I missed that point just a little bit, but that captures the essence of this graph. And then, of course, being thorough here, I want to label my curve with the function itself so that anyone looking at this graph knows exactly what it's all about. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. Remember, you can also come back to this video again and watch it for deeper understanding. If you liked or enjoyed the video, please click like or subscribe down below.